Okay, this is class number 1, Intro to Python, and this is based on Python version 3.7. This is going to be a very exciting class. In this class, we will give an introduction to the Python programming language, its history, why you want to use it, what it may be used for, getting help when using Python, more learning resources that I really like and have really helped me along the way, IDEs and tools that one could use that would help you greatly in learning about Python and using Python, what comes with the standard library in Python, what may be added on to Python or installed after the fact, and then key parts of the Python language like the Python interpreter, the Python interactive console, the various data types, operators, operator precedence, the number and string data types, string formatting, slicing, and indexing, and finally we'll end out this intro with printing. There'll be a lot more to get into after that with this wonderful language that I love very much, but we'll save that for another class. So let's dig in. What is Python? Python is an interpreted, interactive, object-oriented programming language. What do we mean by an interpreted language? Our Python code files do not need to go through a formal compiling process before execution. What do we mean by interactive? Well, two different things. We can make changes to the programs while they are running. That's one way it's interactive. And the second is to make use of Python's wonderful interactive console or Python-specific command line interface. And we're going to get into that. And finally, it's an object-oriented program. You've heard of programs like Java, for instance. Python also has that functionality. Everything in Python is an object, and we can define these objects through defining their data types and how those data types function, and how these objects relate to one another even. This whole topic gets us into Python's wonderful world of classes and methods. We'll get to that. Other useful facts about Python. Python is portable. It runs on many different variants of Unix, Linux, Mac OS, and Windows 2000 and later. Python is a high-level general-purpose programming language that can be applied to many different classes of problems. It can do many things, and in fact, in a slide or two, we're going to explore what those things are. All data in Python program is represented by objects or by relations between objects. Every object has an identity, a type, and a value. An object's identity never changes once it's been created. You might think of it as an object's address in memory. An object's type determines the operations that the object supports. Does it have a length, for instance, and also defines the possible values for objects of that type. And we're going to show you how you can understand what a given type supports through the Python language itself. So it's a very wonderful language, and I'm so glad that you're here with me. And just a little bit of history about the Python programming language. I leave this here for you. This is from the Python Software Foundation, but just a few things to point out. How old is Python? Python is relatively young, right? It was created in the early 1990s by a guy named Guido van Rossum in the Netherlands. Python releases are all open source, and some folks ask the question, how did Python get its name? You know, is it a snake? What's it named after? Well, when Guido began implementing Python, he was also reading Monty Python's Flying Circus, a BBC comedy series from the 70s. So through the power of influence, he settled on Python. This is a wonderful world to go down, but when you get stuck or when you need answers, where do you go? How do you learn more? Well, besides the courses up on my channel, the Yogi Coder YouTube channel, I'd like to expose you to some of my very favorites. I have studied and explored through countless books and websites and YouTube channels and courses, but here are just some of the ones that have really helped me along the way. They might not all be your favorites. It depends how you like to learn, but I tend to like sources that really go into the nitty-gritty details. I don't want to just learn a few bells and whistles or some of the more prominent features. I want to be able to understand things from the ground level up. And I have a real long way to go, but these are some of the things that really spoke to me and called to me. First of all, MIT OpenCourseWare, Intro to Computer Science and Programming in Python. It's a series of 37 videos in total, and it's part of MIT's free online computer science degree courseware. I highly recommend it. Then, of course, there's always python.org, the documentation suite. There is so much up there, not just the tutorials, but documentation and examples and quizzes and other resources. You can go to docs.python.org. By the way, with the MIT stuff, just Google that. Just Google that title as I have it there. The link was too long to be useful through a YouTube channel. Then there's a tool that I love. You should check this out, and I'm sure we'll use it as these courses go on. pythontutor.com. This allows you to visually see your code in action as it executes. This helped me greatly, and I'm sure it will do the same for you, to understand how the code traverses, how it works, what is it doing. Of course, there's always Stack Overflow, which is an online community of different programmers. You can pose a question. Folks will be nice, and hopefully they'll be nice most of the time, and answer your question. They share their knowledge. I've gotten so many questions answered up there. It's been wonderful to me. Of course, there's this channel, and another wonderful resource, Dan Bader, is realpython.com. I've taken his courses. He's fantastic. He's always thinking about things and tends to go into areas that maybe other folks haven't gone into. He's a wonderful resource. Then I'd like to expose you to two different IDEs that I like to use. One ships with Python and one doesn't. IDLE is Python's integrated development environment, and it's wonderful. I show you some screenshots here below. It has two parts to it. It has many parts to it, but two basic parts to it. It has a shell window, as I show you right here, and it has the editor window. So you're able to write your code, and you could press F5 and it will spit out in the shell, or you can use the shell itself. This is actually Python Interactive, and we'll get into that some more. It also has a wonderful debug mode that you can use, again, to watch the code go through bit by bit by bit. It's not unlike Python Tutor, but it's presented in a different form. It's wonderful. You can step over things. You could set different points. It's wonderful, just wonderful. So I highly recommend those. And this is my other favorite IDE. This is the one that does not come with Python. It's called Pycharm, and it is created by a company called JetBrains. And I tend to use IDLE for just straight Python code, but when I'm working on Python in concert with a framework such as Django or Flask, there is nothing else I'm using but Pycharm. It makes it so incredibly easy. It comes with two different versions. I went and bought the professional edition. You see here on the right-hand side, there are a lot more features that come with the professional version, but there's also the community version. But I highly recommend this tool. This tool is phenomenal, and you can use it for everything. I use it for JavaScript stuff. I use it for straight Python as well. Sometimes IDLE is just more convenient. I didn't expose you to what exactly an IDE is. An integrated development environment is a software suite that consolidates basic tools required to write and test software. It has so many of the things that you would need. In fact, I have some Django courses up on the Yogi Coder site, and I go into it in a bit more detail. But go ahead and check it out. There are certainly others that I've used and I've tried in terms of IDEs, but these two are my favorite and my go-tos. So this page is going to talk about all the different things we can do with Python right out of the box. And in fact, it's only a partial listing, but it's some of my favorites. So this is right out of the standard library from Python. We can process strings, such as removing double words, extract specific data based on certain patterns, find and replace words, search for keywords. Of course, you can solve mathematical problems from the simple to the complex. We can manipulate lists of objects, add them together, sort them, compare them, combine them. We can solve date and time problems. We can read and write to files and databases. Python comes with a database called SQLite, so you don't even need to install anything special to get started. You can read properties of and work with operating system file systems, compare files and directories, implement cryptographic solutions, implement event logging for systems and applications, threading interfacing, working with networks and network protocols like SSL, work with data formats that support the internet to facilitate email, working with JSON data and files like CGI, HTTP, SMTP, FTP, etc. Work with multimedia files, create GUI applications with tools like tkinter. And there is also a suite of tools that will help you to write software and to test it. Doc test, unit test. Check it out. There's a ton you can do with this language. Okay, the last slide, we talked about things that come native to Python. This is all about the things that you can add to Python after the fact. Through the Python package index, or PyPI, or as I like to call it, PyPI, you can go to https://pypi.org or pypi.org, and you can install any number of different packages. This is a repository of software that you can use for Python. And you see here some of the stats. It has over 161,000 projects. I use it for many different things, including for web frameworks like Django. That's where I tend to hang out. There are applications that you can use to enhance that Django experience as well. So if you like to do things with web frameworks, or you want to learn about AI or machine learning, or I have Pandas here, which is big on data structure design. There's so much that you can do. Just go up there and check it out. At least at this point, make yourself familiar with what your options are. So how to install Python? Well, if you're a Mac user like me, it comes with the Mac OS. There's nothing particularly tricky about it. Recently, I had called to install it on Windows. Very simple. I just give you the URL here for python.org/downloads, and you're able to access the package that's right for the OS that you're running. All Python releases, as I previously said, are open source, and historically most, but not all, releases have also been GPL compatible. And GPL stands for the GNU General Public License. It's a widely used free software license which guarantees end users the freedom to run, study, share, and modify the software. The Python interpreter is the application that runs your Python script. When you go to your command line and you issue the following command, Python, the name of your script, .py, you are using the Python application to run your script. If you have this line at the top of your Python script, the shebang user bin env Python, this tells your OS to use the Python interpreter on your script. So that should enable you to just do name of your script .py at the command line. So you see here, I give you an example of me doing just that. For me, I have to run Python 3 because Python 2 comes with the Mac OS, and if I want to explicitly run Python 3, I have to tell it to do so with Python 3 space hello.py, or whatever the name of your script is. For Windows, I give you the syntax to be able to add Python to your path statement, and documentation on the Python command line options can be found at the link that I give you here. We can't thank Guido and the boys enough for all the wonderful features that this wonderful programming language comes with. Python interactive mode is at the top of my list. Interactive mode is a Python-specific command line shell that gives you immediate feedback for each statement run. Interactive mode is a really good way to evaluate your code. So how do we launch it? So once again, we're at the command line, and if you were to issue Python and hit enter, in my case Python 3, as you see here, then you will go into interactive mode. When you see the greater than, you know that you're there. From there, you're able to issue commands, and we're going to do that throughout this presentation. I won't go into that now because we'll use it often. But if you wanted to get help, another wonderful feature, type help with the open and close parens, and you'll be able to go into the help utility. From there, you can type whatever you want. You want to learn about Python lists or strings or whatever data type, you're able to do that. To get out of help, sometimes that can be a little crazy. Just type quit, as I have down here at the bottom, and you'll return back to regular interactive mode. The next two slides go into all the different data types that you will run into in Python. I won't read through each and every one, but we will certainly, through the course of all of these presentations and classes, go through many of these. In fact, most of these. So I give it to you here and on the next page to take a look through. In this class, we're going to cover strings, we'll cover integers, floats, booleans to a certain extent, and that's probably pretty much it for this introductory class where we're just laying all the groundwork. But keep this as a reference. What I tried to do with this first class is expose you to all those things that you will need so we can build on. You will refer back to these often. Now I want to expose you to some useful tools that you will probably use all the time. We're in Python Interactive here on this slide. I set a variable x equals 5. Now I say type x, and you see what comes back, class int, letting me know it's an integer. So this type is a built-in method that returns the type of object that you're dealing with. Then further, we can use this dir or dir built-in method that returns a list of valid attributes and methods that you may use for that object. So you might say to yourself while you're coding, what can I use? Well, I can't remember what I can use with an integer, with a string, with a list, with a tuple, with a whatever it is. You can use this dir method to refresh your memory because it's all these things that I have returned here in this box that you're able to use against an integer. So note, an attribute is something the object has, a method is something that it does, and we're going to get into that more and more as we talk about classes down the road. So you see here on the right-hand side, type L1 comes back class list. Notice every type, every data type has its class. So it comes back class list. I know we haven't spoken about this. The next one comes back string. The one after that set. The one after that is a function. So we'll get into all of these, but I'm just using those as examples that you can use this type method to tell you, if you're confused, what type of data object you're working with. The next 7 slides, again, for reference, we are going to go through quickly. But again, you'll refer to them often, so keep them handy. This is an exhaustive list of Python operators. Operators are used to perform operations on values. For instance, the plus operator may be used to add two integers together, such as 2 plus 4 equals 6. Python has the following operator types: arithmetic, assignment, comparison, logical, identity, membership, and bitwise. So we start here with arithmetic, which are probably familiar to most of you, at least most of these. They're used to perform common math operations: addition, subtraction, multiplication, division. Then we have the mod or the modulus or the modulo, right? And that finds the remainder after the division of one number by another. So what's left? 7 mod 3 gives you 1. How? 3 goes into 7 2 times, which equals 6, and then there's 1 left over. It's that 1 that's the mod. Then we have exponential. That's the operation of raising one quantity to the power of another. That's probably familiar to most. And then floor division or integer division is division in which the fractional part, the remainder, is discarded. So 7 floor division 3 results in 2. 3 goes into 7 2 times, which is 6, and we disregard the 1 left over. It could be seen as kind of the opposite or the invert of the mod or the modulus. And on this slide, we have assignment operators. These are used to assign values to variables. This is one of 2 pages on assignment operators. So the first few, we have the assignment plus, the assignment subtract, the assignment multiply, the assignment divide, the assignment modulus, the assignment floor division, the assignment exponentiation. So let's start with the assignment. The assignment assigns a value to a variable. We've seen this already in this short training. A equals 7. A is the variable. It assigns the value of 7. Now all the rest do the same thing, but in a slightly different way. So let's look at the example for the assignment plus. We have x equals 7. and then x plus equals 5 for a total result of 12. Look at the explanation. We start with 7, then we have x plus equals 5, which is the equivalent of saying x equals x plus 5. Right, so if we plug in the number 7, we have x equals 7 plus 5, which gets us to 12. So the x plus equals is the same as x equals x plus 5. And the same could be said for the subtraction variant, the multiply, the divide, the modulus, the floor division, and the exponentiation. Now we get to the bitwise AND. This shows where two sets of data will intersect. It does not actually change either set. And we haven't seen yet, we won't in this particular first class, seen what a Python set is all about. But it really is just a set of elements, right? A set of data. So if you look at my syntax here, set 1 equals A, B, and C, and set 2 equals X, Y, and Z. The result is an empty set, right? Set with just the brackets. Since the operator brings back the elements that two sets have in common, if there are no elements that are in common across these two sets, as is the case here, what will get returned is an empty set. Now, the modify bitwise AND, this AND equals, this modifies the set on the left side of the operator, retaining only those elements found in both. And this does actually change the first set. So once again, if we have ACB and XYZ, and set 1 and equals set 2, if we then fire away on set 1, again we'll get the empty set for the same reasons that we had before. There's just nothing in common between the two. So it does exactly what we'd expect it to do. So I think you'll probably catch on to this second page very quickly because it's very similar to what we just went over with the bitwise AND and the modified bitwise AND. So let's just go over the bitwise OR. So that's the pipe. The vertical line is the pipe. This returns a set of elements, adding any elements from set 2 that set 1, doesn't already have. And just like the bitwise AND, this does not modify the data. So if we look at the example, set 1 is ACB, set 2 is ZYX. The result of the bitwise OR is all the elements. This creates a set of elements that are not in both sets. So the only difference between the bitwise OR and the next one, the modified bitwise OR, does the same thing except it does modify the set. Then we have the bitwise XOR. This returns the set of elements in either set 1 or 2, but not both. So it doesn't actually change the data. And this here we have ABC, XYZ, set 1, bitwise OR set 2. This returns the set of all elements in either set 1 or set 2, but not both. And finally, we have the shift X right by Y, or the bitwise right shift. You might not use these a lot, but I wanted to expose you to it. Bitwise are not like regular numeric operations. These treat integers like binary bits. An application for the uses might be when you're dealing with network packets or serial ports, for example. What it does is it shifts the binary number by n bits. So if you look at the example, we have A equals 60. We turn that into a binary by saying bin A, and we get the binary equivalency. Then we have A bitwise right shift 1, and we get the number 30. Then we bin 30, and we see, yes, indeed, it shifts over by 1. Right, you see from this one example here for 60 to the binary equivalency of 30. Now, this is the equivalency of floor division of x by 2 to the power of y. So I give this example here as well. So x in this case, right, if we're following this language here in the definition, x in this case would be a, and a is 60. Then y would be 1, right? So 2 to the power of 1 is 2. A floor division 2 is 30. So we get the same thing. The same goes for the left shift, just in the opposite direction. Next, we have comparison operators, which are used to compare two values. I think this would probably be very familiar to most people. We have the double equal sign, which tests if objects on either side of the operator are equal. What some folks do when they start out with Python or other programming languages, because Python is not the only one to use this, they'll confuse the single equal, setting a variable, and the double equal, this comparison operator. So beware of that. But these are all pretty simple. So we have, if two things are equal to each other, if they're not equal with the bang equal, then the greater than, less than, then greater than or equal to, and less than or equal to. So you see these examples here. I won't go through them because I think these are pretty self-explanatory. Next, we have our logical operators, which are used to combine statements. We have and, or, and not. And these I'm going to guess you'll be using a lot of. So the and returns true if both statements are true. So we have x equals 4, y equals 5. If x is less than 5 and y is greater than x, the result will be true. So we need both conditions to be true for this to evaluate as true. And then or, the difference there is, returns true if only one statement is true. So 4 is not equal to 2 is true. 4 is not equal to 2 plus 2 is false. Either statement could be true to return true, otherwise false. Not is the opposite of what is true, whether using and or. So it's just the reverse of what we spoke about. So not 4 is less than 5 or 4 is greater than 5 will return false. And why does it return false? 4 is less than 5 and 4 is not greater than 5. So if this did have a not, if it didn't have a not before it, this would return true in a normal or, because one of the conditions is true. You put a not before it and it returns the opposite, right? So it's forced to return false. Now let's look at the second one. Not 4 is greater than 5 is false, or 3 is greater than 5 is also false. So in a normal or, this would return false. So the not in front of it forces it to do the opposite and it returns true. Here we have our identity operators. They're used to combine statements. These are also fairly straight ahead. Is and is not. Is returns true if both values are the same. Is not returns true if both values are not the same. So let's look at the is. X equals 4, y equals 4, x is y. The result there would be true. The is not, x equals 4, y equals 3, x is not y. The result there is true. Two more that you may find yourself using often. Membership operators to test if a sequence is in an object. So we have in and not in. In will return true if a sequence is in a specified object. So let's look at this. And we haven't learned about lists, but that's what we have here. L1 in our syntax example is a list. We have food, fun, and music. S1 equals music. String 1 equals music. So is string 1 in L1? Yes, it is. Now we have not in. Not in will return true if a sequence is not in a specified object. So we have the same thing here. L1, same list, food, fun, and music. And then we have string 2, which is work. Is string 2 in L1? False. String 2 not in L1 returns true. Since S2 is not in L1, it returns true. So rounding out this whole talk on Python operators, we get to Python operators precedence. And you can think of this as what part of a statement, because some of our statements will be complex by the time we're done with all our classes and we start writing our code. What takes precedence? What will be evaluated first? So the following table summarizes the operator precedence in Python from lowest precedence, least binding, to highest precedence, most binding. The operators that are in the same box have the same level of precedence. So you can see some of these things you won't know about. Lambdas, you won't know what those are right now. If-else conditional expressions, we haven't gone through those. But the or, the and, the not, the in, the not in, the is, greater than equal to, multiplication, different things that we've already spoken about, you will see them here. So you'll know what will get evaluated first as you write your statements in your code. So did you know that you could use Python as a calculator? So here on the left-hand side, I have a picture of Python Interactive, or the interactive console. Let's first be very clear on how we would clear the interactive console, because you might want to do that to get rid of the clutter. So once you were at the prompt, the 3 greater than signs, you would press Control plus the letter L, lowercase l. That'll clear the screen for you. But look at Python. We can do 1 plus 2 is 3, 2 times 3 is 6, whatever the case may be. Python has some idiosyncrasies. This third line here does not start flush at the first character space after the 3 greater than signs, so it's indented. Python will throw you an indentation error, as you see here. You have to be flush, or you have to be in the first character space. It also, when you're writing your code, you should know this about Python. If I'm writing a block of code, say within the body of a function or a class or an if statement or a for loop, you must indent 4 spaces. If you don't do that, you'll also get an indentation error. Now, a couple of other things that I have here for you. In Python, straight division will always return a floating point number, also known as a real number. If we use 2 forward slashes, you'll see that that is Python floor division, and it will discard the fractional part. So 10 floor division 3 brings you 3. The inverse of that is mod, or modulus. So 10 mod 3 will bring 1. The mod operator returns only the remainder of division. So 10 divided by 3 goes in 3 times with 1 left over. So it's the 1 left over that represents the mod, or the modulo, or the modulus. You'd hear it said in any of those different ways. 2 to the power of 4, 16th. And you see here, here's where Python does not care about white space. You see how I can have them all in a row, the 2 asterisks, and then the 4, or I can have spaces in between. It doesn't care about that type of spacing. That it's fine with. So let's talk about variables. We touched on it before when we talked about operator precedence and operators in general. In Python, the equal sign is used to assign a value to a variable. What is a variable? A variable is a label or a pointer to a certain value. The value could be just about any object in Python: an integer, a float, a string, a list, a set, a dictionary, etc. And by the way, I know some of those are new to you, but we will learn about them in the courses to come. We are then able to use that variable, that name, that label, in place of that value. And you'll see exactly why we want to do that as we get deeper and deeper into the language. But let's look at what we have in the code snippet here. We create 3 new variables called distance1, distance2, and distance3. We assign them to the values of 4, 10, and 2 respectively. So they represent integers. Then we add them all together using their variable names. And you see we get the total of 16, which is what we expect. Now we can assign the sum of our 3 distance variables to a new variable called total. We do this to be able to conveniently use the sum more easily. So you see down here, once we have total, which is equal to 16, we can divide it by distance 3, which is 2. We get 8. And again, since we're dividing, we'll always get a floating point number. In interactive mode, the last printed expression is assigned to the variable underscore. So underscore here is 8, right? That's the last printed expression. So total divided by 8 equals 2. So let's now use Python to find the area of a room, pulling together some of the things we've learned so far. So I'll show you how to do this in 2 different ways. There are several ways you can do this, certainly. Measure the length and the width of a square or rectangular room. Use the standard 2 times length plus width. That'll get me my perimeter formula to find the perimeter of a room. So we are given values for length and width. 10 is the length, 17 is the width. So now we have a choice. How do we want to figure this out? What I did was I came up with my own variable, L underscore and underscore width, which will equal the length plus the width. Then I came up with a second variable, total area, which takes the length and the width in parentheses and multiplies it times 2. Then I chose to use the print function to get the total area. So that's certainly one way to do it. Print function prints the given object to the standard output device, or your screen, or to a text stream file. In version 3.0, Python replaced the print statement, print, with the print function. If you're looking at, I should mention this to you, it's the difference between 2.x and 3.x. If you're looking at some code that somebody wrote, say in Python 2.7 or something like this, you'll see print without the parentheses, and that's why that is. It used to be a statement, it now is a function, so you have to put it in parentheses on 3.x and beyond. So here's the second way to do it. We take our length, we take our width, and then we take 2 times the length plus the width, and we put it right into the parentheses of our print function, thereby saving us just a few steps there. In this assignment, we'll use Python to calculate 3 different restaurant bills. Our mission, to calculate the total restaurant bill using a 10% tip, a 15% tip, and then a 20% tip. The total bill is given to us as $120. So I expose you here to something new called the multiple assignment statement. The multiple assignment statement evaluates the entire right-hand side of the equal sign first. Then it matches values with destinations on the left-hand side. Because of the complete evaluation of the right-hand side, this construct works nicely to define multiple variables in one fell swoop. You see here I have 10, 15, 20 equals 0.10, 0.15, 0.20, representing our 10, 15, and 20% tip requirement. And then I choose to use 3 different print statements, and we're going to learn about the print statement right at the end of this particular training module. What I have in quotes are literals. So it'll print out 10% total is, colon, then a space, and then it will do the calculations. So I have total times 10, which of course equals 0.10, or 10%, plus total, which is 120. And then we do the same for the 15 and the 20, replacing the 10 with the 15 and the 20, which would be 0.15 and 0.20 respectively, and we use the same total. And of course, we adjust our literal language. So instead of 10% total is, we change that to 15% total is in the second print statement, and then 20% total is in the third print statement. Now we're on to Python strings. Strings can be used to represent just about anything that can be encoded as text or bytes. This may include symbols, words, context of text files loaded into memory, internet addresses, Python source code, etc. Strings are defined as immutable sequences. So they have a left to right positional order and they cannot be changed in place, hence the immutable type. Python has some types that are immutable and some types that are mutable, and we're going to get to those. Let's explore some different strings. So you see string number 1, my_string equals hello, and strings are put into quotes. String number 2, my_string2 equals hi. And you see here, Python doesn't care if I use double quotes or single quotes, as long as we stay consistent. What I start with, I end with. Then strings can be a combination of letters, numbers, spaces, and special characters. And you see here, I have spaces in the sentence, what are you doing, is also a string. I have a question mark in there and I have spaces, so that's permissible. So next we can define an empty string, open and close quotes. And here you see we have x equals don't. So notice I can use my single quote for the word don't as long as I'm using double quotes to encapsulate the entire string. So on the outside I use double quotes, and then before the T I use single. If I wanted to use single for all of those, I would have to escape. We call it escaping that single quote that comes before the T with a backslash. So Python doesn't get confused. But the best way to do it is double quotes on the outside, single on the inside for an apostrophe. We can also concatenate strings. We have adding as our variable equals my string, which is hello, plus then a literal empty space plus my string2, which of course represents hi. So it'll print out hello space hi. And we can concatenate strings in the following way as well. X in this particular case was equal to ABC. If I do X times 4, it simply adds together ABC, 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 and you see that there. The one thing you can't do if you see number 6, we can't use reserved words like the word class. They aren't allowed to be used as variable names. And what I do in the very next slide is I give you a listing of what the Python reserved words are so you can stay away from them, but you'll quickly start to learn what those are. So you may use a number in the variable name, but you cannot start with the number, or you'll get an error like the one we get here for number 7. Syntax error, invalid syntax. This does work though for the second example, 1_1. So spelled out 1_1. That absolutely does work because we're not leading with an integer. Here is that listing of Python reserved words. Again, you would not want to use any of these to name your variables. Keep this handy for future reference. And here we'll dig deeper into Python strings. So up on the left-hand side, we once again make use of the dir method. We feed it, or put in the parentheses, our string one_1 or 1_1, and we get to see all the methods and attributes available to us with any garden variety Python string. So what can we do? If we start on the right-hand side, you see a variable here called make_upper, and I have that equal 1_1, our variable from the previous slide, and I feed that the .upper method. And you see what happens is it used to be yo, lowercase, and that changes it to uppercase. We can then take that and feed it the lower method, and it changes it back to lowercase. We can also test for truthiness. So make_lower dot is lower. Is it lower? Yes, it is. Then I can test for, is it an uppercase? And no, it's not. I can test if it's alphanumeric. Yes, it is. Comes back true. And I can test for if it is a digit, and no, it is not. Then I can concatenate a variable and a literal together. So make lower is my variable plus the word dude. And you'll always know if it's a literal because it'll always be in quotes. Literals are always in quotes, just like strings are. So if I do make_lower plus dude, you see I have yo dude, no space. But if I want the space, you can do it in a number of different ways. One of the easiest things to do is around my literal, just have the first character be a space. So you see here I have quote, space, and then the word dude immediately followed by the closing single quote. And it prints out yo, space, dude. We can also use the len method to get the length of a string. So here I've printed out the alphabet, S equals A through Z there. And if I do len and feed it my variable S, you see it has 26 as an output, just like we would expect. Now, if we go back here to string indexing and slicing, this might be of some use to you, certainly as you go along in your coding career or hobby or whatever you're going to use it for. Strings can be indexed or subscripted with the first character having index 0. We call that 0-based indexing because the very first character is 0, not 1. It starts at 0. So here I have a new_word pizza, and if I want to get the value of the first character, it would be new_word and then in square brackets a 0, not a 1, a 0, and that will bring me back the P. And as I go from there, new_word 1 would bring me back the second character, which is an I. And the third character, I'd have to use 2, right? So I'm always 1 behind what it would be at using normal math or normal counting. So new_word 2 would be the Z. If I want the entire word using indexing or slicing, I could just use a colon. So if I do new_word in square brackets a colon, it brings me back the entire word pizza. If I do new word 1 colon, you don't see the output here, but new word 1 colon would bring me back IZZA because it won't take the first character, which would be 0, and then it takes everything to the end. That's what that colon stands for. In this second box here, new word :1 is the P. There's something we should know about slicing, and we're going to get into this on the next page, but slicing will always take the first character, that's included, but it doesn't include up through, it doesn't include what that second character would be on the other side of the semicolon. So here it's implied that we want 0 because there's nothing on the left-hand side of the colon. And it gives us everything up and through what would be represented by number 1. And number 1 is I, so it doesn't give us that. So it turns out this is the same as if we were to just have a 0, right? Just gives us the P. And we'll go into that in just a little bit more, so hang tight. I just want to show you a few examples on the next slide we get into this. Same thing here. We want 0, but not including what's in 0 based index 3, so it would be PIZ. 1:3 would be just the IZ. And if we wanted the whole entire word, now we see it in a third way to do this. See, Python is extremely flexible in this regard. 0:5 gives us the whole thing. If we do 0:4, it gives us everything but the last A. New word 1: gives us IZZA, and that's what we showed before. New word -1, that gives us what the last character is. It starts from the right-hand side now, so -1 is the very last A. New word -2 gives us Z, the second to last character, starting from the right-hand side working backwards. And -1: starts with the very last character, which is A, and takes us to the end. But since it is the end, it just gives us the A. Same thing with the -2. It starts second from the end and takes us straight to the end of the word, so it's Z and A. Now here, this is an interesting one. We have a colon and then -2. So it starts with the very beginning, and then it takes us up through -2, but not including the -2, right? Because the upper bound value is not included. And again, we're going to get to that in just 1 minute. This is just a precursor to that. Then we talk about stride. So here we have the alphabet, and we know we want from the beginning to the end, but we want it to bring back every other character. So if we wanted every character, our stride would be 1. But since we implemented a stride of 2, it's going to give us every other character. So see here in the output, A skips B, goes to C, skips D, goes to E, etc. So that's what stride is. We can have a stride of 3, we can have a stride of 4. If nothing is there, it's implied that it's a stride of 1. Then I wanted to show you how to reverse a string in a very handy way using Python string indexing and slicing. Hello there, if I do colon, that would give me, we know that, it would give me from the beginning of the word to the end. But if I then do colon with a stride of -1, again, the negative makes me go in the reverse. So I take hello there and I spit it out backwards. So that's an easy way to take a word. If you ever have call to do that, I don't know what the application would be, but if you ever have call to do that, that's how you would do it. Colon, -1 against any string. And that would be the same as, that would be equivalent to 10 to 0, because we have 10 characters there. 10 to 0, and we can do that by 10 colon, and then nothing, 0 is implied if we don't use anything. And then the colon -1, like we did in the other example. Now here, we're going to take a challenge to remove the file extension from a file. So we have file foo.txt. We want to remove the dot and the txt. So how would we do that using Python string slicing? The syntax to remove the .txt is F, and then with inside our square brackets, colon -4. Or -4. So the colon -4 is the same as saying 0 to -4. So it says start at the very beginning of the file and go to the upper bound, which is the dot. But since the upper bound is non-inclusive, this character is not included in the return substring. So it stops at the second O. And this is exactly what we want. Let's really make some of these concepts clear. Slicing rules to remember. The left offset, or the first number given when we're dealing with string slicing, is known as the lower bound, and it is always inclusive. That is to say that it's always returned in the substring. The number to the right of the colon is always known as the upper bound, and it's always non-inclusive. That is to say it's not returned in the substring. So if we look at this word friend, we see here, looking from left to right, 0 is the position that happens for F, 1 for R, 2 for I, 3 for E, 4 for N, and 5 for D. And working backwards, -1 for D, -2 for N, -3 for E, and so on. So looking at the boxes above, 0 through 3 would bring back F, R, I, but not E, because the upper bound is non-inclusive. 5:1:-1, and again, that last -1 is the stride that we learned about. So we're going from right to left with a stride of -1, so we're not skipping any characters. That would bring back D, N, E, I, but not R, because the upper bound, the number to the right of the second number, or the number to the right of the colon, is non-inclusive. And let's talk about a few other things that you might find useful in working with strings. I'm going to go through these pretty quickly, but feel free to stop, examine them, try them out yourself from Python Interactive. That's probably the most important thing. You can capitalize a string using the capitalize method. You could swap the case of a string. That is, if I have a lowercase, it becomes an uppercase, and if I have an uppercase, it becomes a lowercase. You can find the position of a character or a word using the find method. You can count the number of times a character appears using the count method. You can replace one character with another. So in the case of the word food, if I want to replace the D with the L, food quickly becomes a fool. You can replace high with higher in this particular example here. You can split a string. So I have the string, how good are you at coding? And in between the words, of course, is white space. And if I do a split on white space, now you see that I get just those words extracted. That could be useful for the right application. You can also center a string across a finite field of characters, whether it be 25 characters or 35 characters or even 50 characters long. You can join a string to a list, and you see how I do that here. My string is yo, my list, and we'll learn about lists in upcoming classes, Mickey, Minnie, and Daffy. Mickey yo, Minnie yo, Daffy. You can strip off the space at the end of a string using the right strip method. My name is George, and you see we have white space at the end of that before the closing quote. Using the white strip, taking out the space, now we don't. You can strip off the new line character at the end of a string. This may be exceedingly useful in certain applications. So you see we do that here with the rstrip method. And finally, if you wanted to get help on any one of these methods, you could do a number of things, but you can also make use of the help method that we talked about before. We put in line 1 and then .rstrip, and it'll give you some helpful information there as well. Remember to get out of help, type quit. This is another extremely useful topic that I'm sure you'll use quite regularly. This is string object format method. In the first snippet of code, we have a variable called template. And what we have first are substitution targets by position. We can use these by position or by keyword. We'll go through both, but the first one is by position. It instructs Python in which order you want the string arguments that these align to print out in. So the next line are the string arguments that align to the targets. It is these three that get printed out. So in other words, the substitution targets tell you when to print or how to print in what order, and the strings themselves are what gets substituted by the targets. So you see what gets printed out here instead of 0, 1, 2 is hi, hey, hello. The third line of code is where we just combine this all into one statement. So template equals 0, 1, 2 are substitution targets by position, and then dot format, and in the parentheses of the format, just like we did above, we have the strings that we actually want to get printed out, and you see it's the same result. In the next snippet of code, we're still using substitution targets by position, but I wanted to emphasize that instead of 0, 1, 2, here we decide to change the order, and we have 2, 1, 0. Now we have hello, hey, hi. Remember, it's still 0-based indexing. 0 is always going to be the first string that appears in the format parentheses, then 1, then 2. But we can print them out in any order. All we have to do is change those substitution targets like we've done here. The next thing we can do is use substitution targets by keyword. So now you see we have red, green, and blue. No longer do we have numbers, we now have words. And then in the parentheses of the format method, we have red equals hot, right, the string hot, blue equals the string cool, and green equals the string smart. So red, green, and blue translates into hot, smart, and cool. And now we have a slightly more advanced example here. Number one, we're for the first time in this course seeing an import statement. So this is just a module. We'll cover this. The sys module is one of the many, many modules, standard modules that Python ships with. So we're using this because we want to make use of some of the functionality that's contained within the sys module. And we also use a Python dictionary, which I'm sure you'll use quite often. It's a fundamental data type in Python. So we have my one kind, and the number one is used with the dictionary keyword kind in position 1. Then we have the literal runs, and then we have 0.platform. So the word sys here is in position 0. And then we have here number two here at the end, in the parentheses of the format method, we have a dictionary. We have kind and desktop. So kind corresponds to what's in position 1, and runs 0.platform corresponds to what's in position 0 in the parentheses, and that happens to be sys. What gets printed out here is my desktop runs Darwin. So if I do sys.platform, and again, this is a little bit beyond the scope of this, but that's a function of the import statement, right? So we do sys.platform. It says, okay, what platform are you running on? It's something that sys module does for us. It's functionality that gains for us, and it comes out and you're running on the Darwin platform. So we'll get more into the technicalities of these as we progress. Some additional useful functionality as part of the string object format method. So 0:5 is the first positional argument, which should be in a field that is 5 characters wide. So we can have 0:10, 0:15, whatever you want. But what you see here in this first example, 0:5 colon equals, those are the literals. So the things outside the curly brackets will always be literals. And then 1:5 is what? It's the second positional argument, :5, again in a field of 5 characters long. So you see what gets printed out is null, which is that thing, the string, that is in the first position or the 0 position in the format method, and then a 0. Null, colon, equals, and then 0. And both those things, both the first and second positional argument, the 0 and the 1, are in their own individual fields that happen to be 5 characters long. Now in the second example, 0:greater sign 5 is the first positional argument, which should be right justified in a field of 5 characters long. And that third one is the same thing. Greater than 5 is right justified in a field of 5 characters. And then the second positional argument, number 1: less than, I bet you can guess what this is, less than sign 5 is, again, a field of 5 characters long, but left justified. And you can see the output. The output makes sense there. The final example is using the caret character, and that is caret 10. This simply centers the output, and it happens to be here in a field that is 10 characters long, and the second example does the same, only it's in a field of 5 characters. Now we get to new, as of Python version 3.7, literal string interpolation, also known as f-strings. F-strings provide a way to embed expressions inside string literals using minimal syntax. It should be noted that an f-string is really an expression evaluated at runtime, not a constant value. In Python source code, an f-string is a literal string prefixed with the letter f, which contains expressions inside braces. The expressions are replaced with their corresponding values. So here are some examples for you. First name Lucy, last name Ball, profession superstar our F string, which is in this kind of light gray font, F, her first name is, and then in curly brackets, first name. So we know that's going to correspond to our first name variable. Her last name is last name, our last name variable. Her profession is profession, of course, is our profession variable. So we expect that when we print this out, that all of these three variables, first name, last name, and profession, will be replaced with their corresponding strings. So indeed, that's what happened. Her first name is Lucy, her last name is Ball, her profession was Superstar. This is a simpler way to format strings in Python. F-strings provide a concise, readable way to include the value of Python expressions inside strings. And again, you won't be able to make use of this before Python version 3.7. And we have some other examples. In this first example, we use from datetime import date. And just like we did the import statement, this is another way to do an import. Only the format's slightly different, but it doesn't matter for our purposes here. From datetime, the datetime module, import date, the function date. So date equals date, and then the date is 1931/79. So July 9th, 1931. Then we make use of our F string. F date was on a date colon and then percentage sign A. So what happens to print out there, and this is really getting into this whole, we'll get into date and date time and other modules and so much great stuff in Python. We'll get into this, certainly not in this intro class, but it prints out 1931/07/09 was on a Thursday. So it's a function of that date function that enables us to determine what date that was in. But really here, we just wanted to show you some of the great functionality you can use with F string. Other examples, items. Hi, how are you? F string, number of items in, and then we can use the length function, len, use items in parentheses there, like any other function. We're always going to put something in parentheses when we're using a function or a method, and it takes back items, and there we print out the literal number of items is, and then it counts how many items are in hi, how are you, and there are 16 characters there. And finally, F number of items is, and then we can do len items times 10. And I do this just to be able to slowly start to build on some of these concepts and string them together as we're using them. So you actually see within an F string, you can use a method to tell you the length of the string and then multiply that times some number. So I'm just trying to, not that this is very useful, I'm just trying to show you how all these things work together. And finally, we're going to cover printing in Python, and we've already started to see what the print method does. And I've given you the description and the definition of the print statement, but now let's go into it just a little bit because it certainly will be something you use all the time. Objects to be printed. The star indicates that there may be more than one object. Absolutely true. And most of the cases, in many of the cases, that will be the case. Sep, our objects are separated by a separator. The default value is, an empty string. So you don't need to use that. That's not a required element of the print statement. And then end is printed at last. So it's the last thing that gets printed, appended to your object that you want to print out. File must be an object with write string method, and that's exactly how we used it here in our example. If omitted, standard out will be used, which prints objects onto the screen, right? So if we don't explicitly tell it to print to a file, it's going to just print to our screen. And flush, if true, the stream is forcibly flushed. The default value here is false, and I can honestly say I've never flushed a print statement. And if you use sep, end, file, and flush, they all must be given as keyword arguments. So that's when we have that name, that label equals, that key equals some kind of a value. And we've seen keyword arguments in Python. Python uses those a lot as well in dictionaries and other places. So printing to the Python interactive console. So print, and then again, since now print is a method, no longer a statement as of 3.x. Hey mom, I'm printing something in Python, has to be in your parentheses, like any method that we would use in Python, like any function we'd use in Python. So hey mom, I'm printing something in Python. So it's simply printing that literal string, anything in those quotes. So then we have print 1, 2, 3, and we're going to use a separator this time to show you how separators work, of 3 dashes. And notice in there that we use a space before we start those 3 dashes. So that'll print 1, followed by the separator, 2, followed by the separator, and then 3. Doesn't get printed out. That separator doesn't get printed out the third time. We can also send the print output to a file. So my file, and certainly not going to get into file reading and writing in this particular class, but we certainly will in an upcoming one. My file equals open, myfile.text. We'll write. That's what the W is for. And then what do we want to print? Same thing here. Print, I am writing some stuff that I expect to see in my text file, and then file equals my file, right? So we define what the file is, and then we have to use it in our print statement there as a keyword argument, and then we close the file. And here, down below, here is what gets printed to that file. Just exactly what you would expect. Exactly everything that's in single quotes. Over to the right, printing from within a Python file. So now I'm not using Python Interactive. I'm not printing to an actual file, but I'm in a Python file that I've created called printing.py. And I'm using idle, the IDE, to do this. So we learned about idle back in the beginning of the presentation. So I print Claudia, my name, and then end equals the @sign, and then I print Yogi Coder. So what you'll see here is it will print Claudia at Yogi Coder. Now, if we don't want them on the same line, what we can do is we can do exactly what we did before, but in that end statement for the keyword, now we'll have the @ and then we'll have a \n, which is the character for a new line. So now you see how this gets printed out. Claudia @ and then a new line will take Yogi Coder. And we're going to end this fabulous class number 1 by bringing all these concepts together in a challenge for you. So I have the challenge on this page, then I ask you to stop, try to figure it out, and then if you get stuck, come back and look at the next slide, and that'll end our presentation. So what are we doing here? We're using the two statements below, statement 1 and statement 2, print them out to the console, and format them each in a field of 40 characters using f-strings. I mean, we can do this in different ways, but we want to use f-string formatting for practice, and be sure to center them in a field that is 40 characters wide, and also separate the two sentences by using the following characters: 2 equal signs and 1 greater than sign. So the statement 1 is I fly in an invisible plane, and statement number 2 is my name is Wonder Woman. And the output should look just like this. So again, stop the video, go back, look at some of the previous slides, and see if you can't figure this one out. It'd be a good way to tie us all together. Oh, did you figure it out? I bet you did. Let's see what you came up with as compared to what I came up with. I have 2 strings, right? 2 variables, statement and me. Statement is I fly in an invisible airplane, and me is my name is Wonder Woman. Then I go right to a print statement or a print method using an f-string. Then I have a set of curly braces, statement, which of course is my first string, colon, the caret to center it in a field of 40 characters. Then I have my requisite equal sign, and greater than sign, which is a literal, that'll get printed out. And then I have my second string, me, colon, caret again, 40 characters, and it prints out exactly what we want. I fly in an invisible airplane, equal, greater than sign, my name is Wonder Woman. So it's exactly what we need.